Here's a new solution from Analog Devices that offers big advantages for next-generation energy meter design. Advantages that include more architectural flexibility, smaller size, form factor, lower cost, plus better immunity to magnetic tamper. Hi, I'm John Petrus, Product Marketing Manager for IPN, and I'm here to demonstrate the ADE7913, the industry's first fully isolated analog-to-digital converter designed for polyphase energy metering applications. The ADE7913 has 3 input channels, a sigma delta A to D converter that incorporates Analog Devices' patented iCoupler and isoPower technologies to implement isolated signal transfer and DC-DC power conversion across a 5 kilovolt rated insulation barrier and an SPI output. In an energy meter system, a mains AC voltage is converted with a voltage divider to a much smaller level, typically plus or minus 500 millivolts. One of the most common sensing elements employed in energy meter designs today are current transformers and shunts. But current transformers have many drawbacks. They've been around for decades, and they're mature technology that hasn't improved much over the years. CTs are also prone to interference and tamper from external magnetic fields. This can lead to billing errors when meters will undercount or stop working altogether. An unfortunate situation for the utility company providing the power. Lastly, CTs are expensive, physically large, and quite heavy, making it more challenging to meet competitive bill of material costs and tight form factor requirements. This is especially true for DC-tolerant CTs, and also situations where additional shielding is needed to pass regulatory requirements. The ADE7913 has integrated isolation and enables the use of shunt resistor sensing elements instead of current transformers so that all of these drawbacks can be avoided. So let's take a look at our demonstration that we've set up. Here are 2 meters that perform the same basic function of measuring energy consumption. One meter uses current transformers and the other uses shunts. Note how much larger and heavier the current transformers are. Both of these meters are measuring energy consumed by a load. And the LCD readout shows RMS of the measured current. For the demonstration, I'm using a permanent magnet with a surface field strength of about 0.65 Teslas. When I place my magnet in close proximity to the current transformers, you can see it degrades its sensing properties and the LCD readout is almost 0, which we know is not correct since the load is still active and consuming the same amount of energy. The magnet is causing the meter to stop working properly. When I remove the magnet from close proximity to the CT, the meter functions correctly again. Now, when I use the same magnet and place it close to the shunt-based meter that uses the ADE7913, you can see that the LCD reading is consistent and the meter continues operating correctly. I've demonstrated 2 very different meter designs. One meter uses smaller, lighter, less expensive input sensors, and it's totally immune to external magnetic interference. And it used the ADE7913, the industry's first fully isolated ADC for polyphase energy metering applications. Thanks for watching. To learn more, please visit analog.com/ADE7913.